River, stay, good girl. Hey class, this is River. We're going to see if she can get the dog food that's in these Frisbees that are numbered from -3 to +3 and see how she does. River, stay, stay. Okay. And she went for the +2. And let's see what happens after she eats out of the 2. She curves on over to the -1. And that is my dog River. Everybody, so you just met my dog River, and I put some food in some Frisbees, and she went ahead and went over to the +2 Frisbee, and she got some food from there, and then she curved back over and she came to the Frisbee that had the food in it, which was -1. And she kind of curled, and so, you know, maybe she met, I don't know what's in the middle of these, like a half would be in the middle, right? So we got 1 and 0, so in the middle would be like a half, and then she kind of curled, so we maybe had a little of a parabola that looked like that. And if I wanted to make an equation out of this, there's a quadratic equation that goes through those numbers, and it's pretty straightforward to think about how this happens, as long as we think about the fact that we know that zero product property helps us find zeros, or helps us find the x's. It helps us find the answers. So if I treat these as 0 points, which they are, that's 2, 0, and this is -1, 0. Watch what happens when I go to turn these into factors into a quadratic equation. So we got y equals, and I'm going to think about how to get to 0 if the x value is 2. So if the x value is 2, how do you get to 0? You minus 2, right? So the x value, right? The x value, if I plugged in 2, 2 minus 2 would give me 0. So if you ever want to hit a +2 in a graph, all you got to do, put in your factor, put in your parentheses, is x minus 2. Because again, you'll plug in a 2, 2 minus 2 will get you 0. What do you think? How do you get the point -1, 0? Well, plug in a number. If I have to plug in -1, I think that I can add 1 to get to 0. Now I got to make this an x, so it's a quadratic. It's an x squared, x times x. And again, plug in -1. -1 plus 1 is 0. That'll make it hit that point. So if you go to like Desmos right now, or graphing calculator, and you try to graph that, you're going to get this parabola. And you could set up the factor boxes kind of the opposite that we've been doing. These are the two sides, the base times the height, x minus 2 and x plus 1. X times x is x squared. That's where we get that parabola, that U shape, that curve, right? And then I get x times -2, so it's -2x. And then I get 1x, you can fill in the box. And then 1 times -2 is -2. If I combine all these up, what would be the problem that maybe we started with? It would be the x squared. And then we have 1x minus 2x, so that's -1x. And then I got minus 2. That is your y-intercept. Take a look at the y-intercept would hit right here, but you'll learn that a little bit more in Algebra 2. Right now, we can see that our key points on the graph, -1 comes from a factor of x plus 1, and +2 comes from a factor of x minus 2. Again, what's your proof? Go ahead and plug it in. You can always plug it in to prove in math, right? If you plug in 2, will you get 0? You plug in 2 minus 2, you get 0. If you plug in -1, will you get 0? Plug in -1 plus 1, you get 0. This is the equation and how we make it happen to hit between the 2 points that my dog got the food out of her Frisbees. Alright, so we're going to switch it up. Instead of knowing what the key points and what the parabola looked like, we're going to give the quadratic equation right away and see if we can graph it without having to multiply it out. It's already factored, so you say thank you very much. Whenever you see those parentheses, use that zero product property you take x plus 3, you set it equal to 0, you do some easy math, you subtract the 3 on both sides, and we get x equals negative 3. Guess what is a key point on the graph? X-axis, go to negative 1, negative 2, negative 3. See how that's kind of opposite of what the parenthesis looks like? I think some of you guys have figured out that shortcut already. But yeah, you just use the zero product property, solve for x, and there is negative 3 that is going to be one of our key points on the parabola. Can you already guess what the key point's going to be there? Positive 1? Yeah, here's your proof. Set it equal to 0, zero product property, we know how to do that. Add 1 to both sides, x equals, oh, there's that positive 1. It's like the opposite of the parentheses. Again, if you plug in 1, you're going to get 0, so we're going to go plot the point, 1, comma 0. Alright, 1 comma 0, negative 3 comma 0. We can draw the parabola. If we really wanted to figure out like what was the middle point or what was the y-intercept that it hits down here, we can go ahead and you can multiply this problem out, right? X times x is going to give you x squared. You'll get some x's. 3 times negative 1 is going to give you negative 3. So that's going to be your y-intercept. Alright, you could draw a little parabola. So it's very, very easy to use the zero product property. Set each of these factors equal to 0, and then you just plot them. Once you get x equals negative 3, you just go plot negative 3 on the x-axis. This is the x-axis, right? Once you set it equal to 0, solve the zero product property, x equals 1, you just go plot 1 on the x-axis and you're good to go. So here we got another quadratic, but this time this one is not factored. Are there any key points I can find right away without doing any math? Yeah, if you plug in 0 into this, you're going to get negative 6, right? 0 squared, 0. 1 times 0, 0. And then you have negative 6. That's your y-intercept, kind of like y equals mx plus b, our beginning. Our y-intercept is negative 6. I could go ahead and plot that, but that doesn't really tell me where the parabola is. I could draw hundreds of parabolas through this. I could draw a negative parabola, I could draw a positive parabola, I could draw a really wide parabola, I could draw a really skinny parabola, so I really don't know yet. So we need to go ahead and factor what we've been doing all chapter. Factor to find these key x's. Where is this parabola going to curve and hit as it comes up? It's not always even. Sometimes it's shifted left and right. Like maybe it looks like that. Maybe it's way past 6. I don't know what these x's are until I factor. So don't rush through the problem. We're just going to do what we've been doing all chapter. We know how to factor on this problem, right? So I go ahead and I set up my boxes. And I set up the x squared. And I skip that and I go set up the negative 6. And I go across the diagonal and that's negative 6x squared. Ways to factor negative 6 are 1 times negative 6. Or flip it, negative 1 times positive 6. Or I've got negative 2 times 3 or 2 times negative 3. Again, I could flip it. When I got the negative, I really got to watch where that goes, so I just wrote them all out. How can I get 1x? Think. Right there. If I took 3x's minus 2x's. So if I had 3x's minus 2x's, that'll give me 1x. Cool, so we go ahead and factor. We got our x squared, that's x times x times negative 2, x times a 3. Awesome. An equivalent equation, a same equation that's equal, is x plus 3 times x minus 2. Now we can easily get some key points to this graph using the zero product property. Take x plus 3, set it equal to 0. Subtract the 3, you get x equals negative 3. Some of you are figuring out that's a shortcut. If you see x plus 3, you're going to have a negative 3 on your graph. Negative 1, 2, 3. And if you see x minus 2, just go ahead and set it equal to 0. Sorry, it's getting a little crammed here. I'll erase my factoring. X minus 2 equal to 0. Add 2 to both sides. We get x equals 2. Some of you guys are realizing if it's minus 2 in the problem, you're going to see a positive 2 as your other x-intercept, right? We solve for our x's, we graph those on the x. Now it's a little bit easier to see, and it's not balanced, right? This is at 2 and that's at -3, so the middle is maybe a little bit over here, and we have a parabola that goes up through there, and a parabola the other side of that x squared. So we got an x on both sides, and our parabola would look something like that. Hey everybody, we're gonna head to Desmos for a couple problems, and I got River with me, so she's gonna help out with all that she knows about quadratics and parabolas as I share my screen here. Cool, so I want you to think about what would be the factored form of this, which I know you guys can factor, and I know you have those skills, but can you use the graph to help you out to figure out the factors right now, okay? So take a look. If we've got this key point, the 0, we learned the zero product property, right? This key point, the x-intercept, the x is at 4, what do you think one of the factors should be? Y equals, and then we need something in here to be an x, right? We need another x, so we get that parabola, right? So how can we get this blue parabola to match up? How can we come up with a factored form without setting up the boxes? Can we use the graph? So if we want +4 to be a key point, what we're going to do is we're going to put in x minus 4, and boom, you see that it goes through that 4. We got that part, right? Cool. So if we want +4 to happen in our factor, there's going to be a -4. Cool. Let's take a look at this one over here. This one over here is at -0.5. -0.5. Think about how we could get an equation that would help us out for -0.5. What equation do you know that could work for -0.5? Ooh, what about x plus 0.5? Ooh, we got it. See it right there? What's the issue though? Something else is missing out of this parabola. Like the blue one only goes down to -5, and our red one goes down to like -10. So what often happens, like we need this one to go twice as deep, right? Twice down, the blue one needs to match up. What often happens when you have decimals, it's not going to show up as x plus 0.5. Watch what happens if you double both parts of this, right? If I just doubled this decimal one, it's going to turn x into 2x, and then it's going to turn 0.5 into 1. So 2x, and then 1, and look at that now. The red and the blue are matching. The reason that happened is that 2 that was out front, right? That 2 that's out front. So what we learned about factoring earlier in the chapter, that key to the boxes is multiplying that diagonal. In this case, it would have been 2x squared times -4, and -8 would have been the number that we would have had to factor, and these would be our factors that would work for this problem. Okay, what do you guys think would be a parabola that went through 7, 0 and 1.5? Yeah, 1.5, 0. I'm just making this up, right? So what would be a parabola that would go through both of these points, right? Well, the 7 should be easier. How do we make a +7 happen? Let's go with y equals, and then x minus 7. Ah, and there it is. We know about lines and how they work, but we need another x that would work, and there's the parabola, but that also goes through 1.5. So +1.5, we're going to put x minus 1.5, and now we got a parabola that's hit both of those, right? But oftentimes whenever we have these decimals, we're not going to see the decimals. It means it was probably a 2x squared or a 3x squared or a 4x squared problem. So think about how to get this to a whole number, right? We can go ahead and double that, right? So I can either just put a 2 all the way out front, but normally the way we're going to see it in factors is if we just pick this decimal one and we double it. So it's got to be everything in this parentheses. It's a group. So I got to take this x and make it 2x, double. And then -1.5, if we double that, it's going to be -3. And you can still see we've got
x minus 7 goes through positive 7. And 2x minus 3, if you solve that for 0, add 3 to both sides, divide by 2, 3 divided by 2, 1.5. There it is on the graph. Cool. Let's do another one real quick. Just real quick. One that we haven't seen before. 0.25 and then -5. Cool. I think everybody here could finish this up fairly quick. How do we get -5 to happen? That's an x plus 5. There you go. You see it goes through the -5. How do we get 0.25 to happen? It'll be an x minus 0.25. And, oh, messed up, wrong parentheses. We can see that we hit those 2 points that we were looking for, right? We are going through those 2 red and green points, but this decimal is often not going to look like that. I picked this one real quick because it's not a double. How can you turn 0.25 to a whole number? What do you need to multiply by? 4. So if I multiply this whole group by 4, that's going to turn into a 4x. And then multiply a quarter by 4, that turns into a 1. And let's see, do we still have the parabola through those 2 points? Yeah, we do. Cool, thanks for joining in for one little quick other problem.